Hello, chemistry students. Today we're going to be performing our density experiment. So in this experiment, we're going to be learning how to determine the densities of both solids and liquids. Let's get started. Okay, so for part one of this experiment, we're going to be determining the density of unknown solid metal samples. So our first unknown is unknown A. So we're going to use our analytical balance. And the mass of unknown A is 29.2207 grams. Okay, so now we're going to determine the volume of our unknown cylinder by displacement. So we first need to take our 50 ml graduated cylinder, add some water, so here's the volume of water that we added. That's the volume of water that we added to our graduated cylinder. We're now going to take our unknown A metal cylinder, and we're going to carefully add it to our graduated cylinder with the water. And now we'll determine the new volume in the graduated cylinder of the water. Okay, so this is the volume of the water plus the graduated cylinder. You'll now need to determine the volume of the volume of the metal cylinder by displacement. Now we're going to determine the mass of unknown metal cylinder B. The mass of unknown cylinder B is 57.1067 grams, or 57.1066 grams. Okay, so now we're going to determine the volume of metal cylinder B using displacement again. So we're going to add some deionized water to our graduated cylinder. And we'll determine the volume of the water in the graduated cylinder. And this is the volume of water in the graduated cylinder. Now, we're going to add our metal cylinder to the graduated cylinder. So we'll take unknown B, and we'll carefully add it to our graduated cylinder. And now we will determine the new volume of water plus the graduated cylinder. So this is the volume of water in our graduated cylinder with the unknown B metal cylinder. You'll need to determine the volume of unknown B using displacement. Okay, so next we're going to move on to unknown metal cylinder C. So this is unknown C. And we're going to determine the mass of unknown C. So the mass of unknown metal cylinder C is 18.0910 grams. Okay, so now we're going to determine the volume of unknown C by displacement. So we'll add water, deionized water, to our graduated cylinder. We'll determine the volume of water in our graduated cylinder. So this is the volume of water in our graduated cylinder. And next, we're going to take our unknown metal cylinder C, and we will gently add it to our graduated cylinder. And then we will determine the new volume of water in the graduated cylinder. And this is the volume of water in our graduated cylinder with unknown metal C inside the graduated cylinder. You'll need to determine the volume of unknown metal C by displacement. Okay, so now we're going to determine the mass of unknown metal cylinder D. So this is unknown D. The mass of unknown metal cylinder D is 29.2273 grams. Okay, so now we're going to determine the volume of unknown metal cylinder D by displacement. So we will add some water, some deionized water, to our 50 ml graduated cylinder. You will determine the volume of that water in the graduated cylinder. This is the volume of water in our 50 ml graduated cylinder. And next we are going to add unknown metal cylinder D to our 50 ml graduated cylinder gently. And then we will determine the new volume of water Well, this is the 30 mark. Camera's not focusing right now, so. Okay, well, we're going to go ahead and move on. It's about 32 milliliters. So you'll need to determine by displacement the volume of metal cylinder D. Okay, so in part 2 of our density experiment, we're going to be experimentally determining the density of an unknown salt solution and then determine the percent of salt in that solution. So to begin this experiment, we first need to take a 25 ml graduated cylinder, and we're going to determine the mass of this cylinder. Okay, so the mass of our 25 ml graduated cylinder is 54.2291 grams. Now we're going to take our 25 mil graduated cylinder and we're going to add about 20 milliliters of deionized water. So we'll add our water. Then we're going to determine the exact volume of the water in our graduated cylinder. So this is the volume of deionized water in our 25 mil graduated cylinder. Now we're going to determine the mass of our 25 mil graduated cylinder plus the deionized water that we had added. So here's our 25 mil graduated cylinder with the deionized water. And this is the mass. So the mass of our 25 mil graduated cylinder plus the volume of deionized water that we added is 73.7976 grams. Okay, so now we're going to determine the densities of standard salt solutions. So first, this is our 25 mil graduated cylinder that we've been using. It has our deionized water in it. We're going to dump the deionized water. And this is our first standard salt solution. So it's 2% sodium chloride. So we're first going to rinse our graduated cylinder with 2 to 4 milliliters of this salt solution. And then we'll dump it out. And now we're going to add 8 to 12 milliliters of our 2% sodium chloride solution. That's good enough. And then we need to determine the volume of the solution in our graduated cylinder. All right, so this is the volume of our 2% salt solution in our 25 mil graduated cylinder. We're next going to determine the mass of the graduated cylinder plus this volume of 2% salt solution. Okay, so the mass of our 25 mil graduated cylinder plus the volume of 2% salt solution that we added is 64.7475 grams. Okay, so we're going to dump our 2% salt solution. And the next standard salt solution we'll be using is 4% sodium chloride. So we're going to rinse our graduated cylinder with a couple milliliters of this 4% sodium chloride solution. Dump it. Then we're going to add 8 to 12 milliliters of 4% sodium chloride to our graduated cylinder. That's good enough. Now we're going to determine the volume of our 4% salt solution in our graduated cylinder. So this is the volume of our 4% salt solution in our graduated cylinder. Sorry. Now we're going to determine the mass Okay, so the mass of our graduated cylinder plus the volume of our 4% salt solution is 65.0549 grams. Okay, so we're going to move on to our next standard salt solution. So we're going to dump our remaining 4%. Our next standard salt solution is 6% sodium chloride. We're going to rinse our graduated cylinder with a couple milliliters of 6% sodium chloride. Then we'll dump. And then we're going to add between 8 to 12 milliliters of our 6% standard salt solution. And then we're going to determine the volume of the 6% sodium chloride that we added to our graduated cylinder. Okay, so this is the volume of our 6% sodium chloride solution. We're now going to determine the mass of the graduated cylinder plus this volume of 6% sodium chloride standard. Okay, so the mass of our 25 ml graduated cylinder plus the volume of 6% standard salt solution that we added is 65.3601 grams. Okay, so we're going to move on to our next standard salt solution. So we're going to dump our remaining 6%. Our next standard salt solution is 8% sodium chloride. So we'll rinse our graduated cylinder with a couple milliliters of 8% sodium chloride. Dump it. And then we'll add 8 to 12 milliliters of our 8% sodium chloride standard solution to our 25 ml graduated cylinder. Then we'll determine the volume of the 8% sodium chloride solution that we added to our graduated cylinder. So this is the volume of 8% sodium chloride solution we have in our 25 ml graduated cylinder. Now let's go determine the mass. Okay, so we have our 25 ml graduated cylinder plus the 8% salt solution that we added to it on our analytical balance. And the mass of our 8% salt solution and the 25 ml graduated cylinder is 66.2425 grams. So now we're moving on to our last standard salt solution. We're going to dump the remaining 8% standard salt solution. Our last standard salt solution is 16% sodium chloride. So we're going to rinse with a couple milliliters. Dump. And then we're going to add 8 to 12 milliliters of our 16% standard salt solution to our 25 ml graduated cylinder. And then we will determine the volume of the 16% salt solution that we added to our 25 ml graduated cylinder. This is the volume of 16% standard salt solution we have added to our 25 ml graduated cylinder. Now we'll determine the mass. Okay, so the mass of the volume of 16% salt solution that we added and our 25 ml graduated cylinder is 66.3519 or 18 grams. Okay, so now you should be able to determine the densities of those known standard salt solutions. And so we're going to move on to our unknown salt solutions, and we'll be determining the densities of unknown salt solutions. So we're going to dump the remainder of our 16% standard salt solution and the first one we're going to be doing is unknown number 1 salt solution. So we're going to rinse our graduated cylinder with a few milliliters of the unknown salt solution. And we'll dump. And then we're going to add about 20 milliliters of our unknown number 1 salt solution to our 25 ml graduated cylinder. Okay, and then we're going to determine the volume of unknown salt solution number 1 that we added to our 25 ml graduated cylinder. So this is the volume of unknown salt solution number 1 in our 25 ml graduated cylinder. We'll now go determine its mass. Okay, so the mass of our unknown salt solution number 1 plus our 25 ml graduated cylinder is 74.9448 grams. Okay, so we're going to move on to our second unknown salt solution. So we're going to dump the remaining unknown salt solution number 1. This is our unknown salt solution number 2. We will rinse our 25 ml graduated cylinder with several milliliters of unknown salt solution number 2. We'll dump out the rinse. Then we're going to add approximately 20 milliliters of unknown salt solution number 2 to our 25 ml graduated cylinder. Okay, and now we're going to determine the volume of unknown salt solution number 2 in our 25 ml graduated cylinder. So the volume, this is the volume of unknown salt solution number 2 in our 25 milliliter graduated cylinder. Now let's go determine its mass. Okay, so the mass of unknown salt solution number 2 plus our 25 milliliter graduated cylinder is 74.2133 grams. Okay, so we're going to move on to our final unknown salt solution. We're going to dump the remaining unknown salt solution number 2. And we're going to be using unknown salt solution number 3. So we'll rinse our graduated cylinder with the several milliliters of unknown salt solution number 3. We'll dump out the rinse. And then we're going to fill our 25 ml graduated cylinder with approximately 20 milliliters of unknown salt solution number 3. And then we are going to determine the volume of unknown salt solution number 3 that we added to our 25 milliliter graduated cylinder. Okay, so this is the volume of unknown salt solution number 3 that we've added to our 25 milliliter graduated cylinder. Now let's go determine the mass of unknown solution number 3. Okay, so the mass of our 25 milliliter graduated cylinder plus the volume of unknown solution number 3 that we've added to it is 75.4243 grams. So this concludes the wet lab portion of our density experiment. You will now need to create a standard curve using the densities and the percent salt concentrations of our known standards, the 2, 4, 6, 8, and 16% standards. And from that standard curve, you should be able to determine the percent salt concentrations of the 3 unknown salt solutions. Thank you for joining me for this density experiment.